Hi, Year 11. This is Mr. Leah, award-winning math teacher, recently voted best math teacher in South Wales. Now, to give you a bit of an education, I'm going to talk you through some of these booklets. This is a bit of a test one, so it'll be a little short snippet, but we're going to start. Hopefully you can see this, looking at booklet A, which is your number non-calculator work. Now, this little video is going to concentrate on the first two topics, indices and recurring decimals. Should be ones that you know quite well. Let's open up and have a look. Okay, let's start by having a look at the general rules here. I'm using A to represent any number. Any number to the power 0 is 1, your first rule. Okay, A to the power, and I've got a fraction here, 2 over 3. The bottom number of the fraction is your root, and the top number is your power. So this will be the cubed root of A squared, as opposed to the square root of A cubed, which is 3 over 2. The final one, any negative power, you can see that hopefully, means you need to take the reciprocal of that number. In most cases, that'll be 1 over. For example, the reciprocal of 4 is 1 over 4. Now, a lot of these questions I've already filled in, so you can pause when once I've completed these pages, and you can use it to mark your own work, hopefully. Some I've left blank, and I'm hoping to talk you through those in the next 5 minutes. So let's start with the first one. 16 to the power minus a half, okay? Let's ignore the minus a minute. The bottom number, that 2 on the bottom of the fraction, means that I need the square root of 16, which is 4, okay? And then the negative is the reciprocal of 4, which is a quarter. The next one I'm going to have a look at for you, simplify this. 8 to the power 2/3. This time, the bottom number of the fraction is 3, so I need the cubed root of 8, which is 2. 2 squared, the top number there, 2 squared, which is 4. And this time I just leave it at a 4. If this was a negative fraction, then we'd need the reciprocal, 1 over 4. Everything else on this page is done for you, so let's take a pop over to the second page. There's an example here of the power 0 and the answer being 1. This I found a little bit nasty. Quite unusual that we had a power quarter, so we had a 4 at the bottom of that fraction, meaning I need the 4th root. Unusual, don't see that often. The 4th root of 81. What number times this by itself 4 times to make 81? And the answer is 3. Okay. The second thing is 25 to the power minus a half. Again, the half means the square root of 25, which is 5. But because it's a minus, I need the reciprocal of that, which is 1 over 5. The question asks me to multiply these together here. So I'm going to do 3 times 1/5, which is 3/5. And you don't need to go any further than that. Okay. The only other one I'm going to look at on this page, just a little bit tricky I suppose, but I'm sure you'll be fine, is 400 to the power minus 3 over 2. Okay, let's start with the bottom again, the square root of 400, which is 20. 20 times 20 is 400. And then take the 20 and cube it. Okay, 20 times 20 is 400. If I times that by 20 again, I get 8,000. And then the negative, meaning to take the reciprocal of that, which is 1 over 8,000. Okay, I'm going to leave that page there. If you would like to, just pause the screen now and you can answer your own questions. And for those who stuck with this video or not nodded off to sleep, let's turn over and take a look at this page. Again, a lot of them are answered for you. I thought we'd have a look at this last one, only because it's a fraction to begin with, quite unusual. Again, it's minus 1/3. Hopefully you can see that on the video. The 3 on the bottom, again, is the cube root, but I need to take the cube root of both these things. So it's the cube root of 27 over the cube root of 8, which is 3 over 2. Now, as I said, the minus normally would mean 1 over, but the reciprocal of 3 over 2 just means to flip this fraction and would become 2 over 3, 2/3. On to recurring decimals, the final bit of our first video. Express 0.34, I don't know if you can see that there, that 4 is recurring, so 0.344444, and so on. As a fraction, remember our method. We write what's after the 0, 34, over anything recurring gets a 9. So for this 4, I put a 9. Anything not recurring gets a 0. But I take the non-recurring bit, in this case the 3, away from the top. Final answer, 31 over 90. Again, if there's anything on that page you want to stop and mark, hit pause now, and we'll go on to the final page of the video, which is this. Might be worth you taking a look at these down here, okay? If you need to decide whether a fraction terminates or is recurring, terminate means just comes to an end, you'll need to divide the top by the bottom like I've done in these 3 examples here, and then decide whether that is something that would terminate or recur. Have a go yourself, but the answers are there for you. I've deliberately left the top one here for me to try. Express 0.034 as a fraction. You've got to stick to these rules, okay? That 0 after the decimal point is important. The number at the top is 34. However, the 3 and the 4 are both recurring, so both need 9s. The 0 is a non-recurring integer, so still needs a 0. However, we'd be taking that 0 also away from the top, having no effect. So in this case, the answer is just 34 over 990. I'm going to check that test has worked. If it has, this next video will be slightly longer than this one. Hopefully, these kind of videos will help going forward. This is Mr. Leah signing out.